All right, recording is rolling. We're a few minutes into class. This is Wednesday, November 3rd, because I did a collision cart demo for you guys. I put these carts on that low friction track and they were ramming into each other. Okay, and I'm going to have you guys do this lab over 2 days. So today you guys are going to do the inelastic version where they collide and stick together, and then we'll take the elastic for another day. Okay, so remember, today you're only going to have these carts. Okay. You guys saw one thing I did was that there's some magnets here, so they bam, they'll collide elastically. Right? We're gonna save that one for the future. Right? The ones where the magnets have opposite poles and they go collide and stick, move forward. Right? That's the one we're doing today. Right? So back in the lab stations are all the equipment you need: those carts, the tracks, box full of these lab masses, and also these type pages with these tables. There's two sides, right? One for the future, one for today. Okay? So I'll go over this with you guys, show you guys how this works. So let's do one lab page per team, so you guys can write a few names on one of these pages. Just we'll get going. Right, now, if this is a collision lab, then well, it's probably going to test for conservation of momentum, right? Maybe you want to compare the momentum before collision to the momentum after collision, and that's what it is. So there's actually 5 trials lined up here. Don't know what this looks like at a glance, but well, since I put this together, I know what's going on, which is that this entire row refers to the same trial. This could be like trial number 1 right here, right? And then trial 2, 3, 4, 5, all the way down. Okay, and this is pre-collision and post-collision. Okay, so you got a couple of carts. They're gonna collide. They're gonna stick together and roll on. And supposedly, here, I'll explain it sort of backwards. If you look at the end parts of these tables, we're getting momentum numbers. Now, if you guys are measuring in grams today and also centimeters instead of kilograms and meters, then you're going to have grams, centimeters per second as your momentum unit. But that would be a unit of momentum, right? Some kind of mass times velocity value, right? Okay, but where are those going to come from? Because that's sort of closer to the end of what you guys are doing. Okay? So what's going to lead into that? Let's go back to the beginning of this table. You need mass of cart A, mass of cart B. Now, I do have a digital scale back there, but this is too heavy for that. So I also have a classic triple beam balance. If you can get your hands on that, then I do encourage you to. But I'll give you a shortcut just in case there's too many people and you can't access that, which is this. A single cart by itself, like an empty cart, mass of the cart, I measured this ahead of time. It's pretty much exactly 500 grams. But that's not exactly accurate for this because I taped these magnets on front. So once you add the magnet and the tape and the paper towel cushion, right, all that stuff, I'll say mass of the magnets, etc. All that fun stuff. That's about an additional 50 grams. Okay. So if you just have an empty cart, like as is, so basically this right here, okay, you can call that 550 grams. That's probably really close to what it actually is. Okay. Now later on, as you go on, if you want to change the mass, all you have to do is take these lab weights and pop them in there, and just like I did in the demo a few minutes ago. Okay. And the increased mass by that much. In this case, an additional 500 grams. Okay. All right, so do some example numbers with you guys. Let's say I just have 2 empty carts. So I've got 550 grams and another 550 grams. Just like that, 550, 550. Okay. All right, what's the next couple columns? X in centimeters, how far did it roll? And then how much time in seconds did that take? So you guys are gonna have your stopwatches out. It's definitely gonna be a team effort, you guys will say, because these collisions happen really fast, but there's a bunch of data you have to gather in a very short amount of time, including, can you time how much time it took to roll some distance? This is all leading up to some collision, so that you can calculate, the initial velocity of one of these carts. So I'm gonna make up something. Let's say this cart rolls 50 centimeters and it takes 1.25 seconds to do that. Okay. You say, how many centimeters per second would that be? Right? X over t, velocity. 50 centimeters all in 1.25 seconds. That looks like 40 centimeters per second. That could go right there, like 40 centimeters per second. Okay. What's this next deal? Velocity of the other part is 0. Oh, and I just typed that in all the way down. Okay, actually that's really nice because I'm just saying start the other car from rest. So that it'll simplify this a bit, right? So pre-collision, there's only one cart in motion, so you're only timing one cart. Here's your inelastic collision poster. Okay, so it's basically some version of this, but actually even simplified because mass B is just going to start at 0 meters per second. It's just sitting there at rest, right? It's about to be slammed into. And then, well, this is the after photo, but before you just set this to 0. Okay. So it's the whole table set like, okay. Okay. Now we're back up to what is the momentum before the collision. This is all the pre-collision half right here, pre-collision half of the table. Okay. Oh, let's just mass times velocity. Just following the notes from the last couple of days. Here's your, now the mass of the one moving was 550 grams. Its velocity was 40 centimeters per second. Okay. The other one had also 550 grams, but at 0 meters per second, so you just add 0 momentum. Okay. All the momentum is coming from the rolling cart, is what I'm saying. And that's 22,000 grams centimeter per second. Okay. In the notes last couple of days, we've been doing kilogram meter per second. So let's say kilogram to gram, that's off by 3 decimal places. And then meter to centimeter, that's off by 2 decimal places. So 5 decimal places different. So if you roll back the decimal, 5 decimal places, right, wouldn't that be 0.22 kilogram meter per second? That'd be your conventional momentum units. But if you use grams and centimeters, then it's going to be numbers in the thousands. Okay. Good so far? Right. Now, I guess I thought this was a good idea at the time I was constructing this table. There's a few numbers down here. These boxes are just for what's the total momentum before the collision, which all you have to do is just copy paste this number right here. So like 22,000 grams centimeter per second. Okay. It has the unit. Right? Okay. Then post collision. Now remember, this is only half of the story, right? Then like bam, these carts collide, and then after the carts collide, well, you got to get more data. And however you do this, I guess one way it's very similar measurements, right? So what the mass is, how far to roll it, how much time. So got a second time going on. I guess one way you could do this is you could have a separate lab partner with another stopwatch, or I'm sure there's some way to do it. Maybe some of you guys know. You guys are pretty good with tech. Is some way to hit a button where it stops the first time and automatically starts the second time reading. So if you can figure out how to do that on your phones. What's the total mass? Oh, well, all you have to do is add these masses together. So 550 plus 550, that's 1,100 grams. Okay. And then, okay, how far did they roll and how much time? So let's say you track off another 50 centimeters, and well, if they collide it together and they're going slower, just like you guys saw in the demo, I don't know, maybe that takes like 2.5 seconds. I'll call it 2.5 seconds, something like that, right? To roll these 50 centimeters post collision. Remember, this half of the table right here is all post collision, right? Guys get that? Then, so what's the velocity of the two carts put together post collision? Well, if they rolled 50 centimeters and they did that all in 2.5 seconds, that's looking like 20 centimeters per second. 20 centimeters per second. Right. And then, okay, so what's the momentum post collision? Well, that'd be the total mass, the combined mass of the carts, times the post collision velocity. So that's your 1,100 grams, multiplied by 20 meters per centimeters per second. Look at this, 22,000 grams centimeter per second. What's that? So then, similar ideas before, take this number, copy paste it right down here, and then 22,000. Hey, it looks like momentum was conserved. I see how momentum was conserved. Right. Well, of course, I just made these numbers up, but you should see something pretty similar back in the lab area. Now, if you get numbers like 22,000 versus 18,000 or something, that's plenty close enough. Actually, that would be a really good result because this won't be exact. It actually is a little bit of friction, so you might actually expect to see something like that. There's another idea I want to throw at you guys here, which is what happens to kinetic energy? I should have made a space for that, but I'll just do that here. Right. What is kinetic energy initial versus kinetic energy final, say pre-collision and post-collision? Well, that's some version of 1/2 mv squared, right? So like before collision, right? And then 1/2, and then I got this total mass, AAD, right? Times post-collision speed squared. Right? Now, is the kinetic energy going to be the final, like post-collision, is it going to be the same as before, more than before, or less than before? What do you guys say? For an inelastic collision. Let's run the numbers. So 1/2 times 1,100 grams times 40 centimeters per second. So grams, centimeters per second, right? Being squared. This looks like no, 550. because it's just a single cart, right? The other cart had 0 kinetic energy. So 1/2 times 550 times 40 centimeters per second being squared. I'm looking at 440,000. Now this has weird units. It's going to be gram, centimeter squared per second squared. Okay. You could convert that to joules, roll the decimal back so many spaces, but okay. What about after the collision? So this is 1/2. Okay, now this is the 1100 grams multiplied by, now remember, slow down, it's half the speed of before the collision. So 20 centimeters per second, okay, being squared. So it's 1/2 times 1100 times 20 squared. Okay. Now when I hit enter, some of you guys might know what this number is about to be compared to the original number. Okay. Anybody got a guess they want to verbalize before I hit enter? Here, I'll take you guys through it. The fact that I got double the mass but half the speed, right? Now you might think, well, maybe that washes out, double the mass but half the speed. But the speed being squared, so it's like it counts twice, right? Ooh. So double the mass, half the speed would cancel out, except that we got an extra half factor. So I bet this number is going to be half of 440,000. Let's see if it is. Oh yeah, 220,000. 220,000. It's got these weird units of grams, centimeters squared per second squared. But that is an energy unit, just kind of weird. Right? You guys get that? Right. Okay, so before I send you guys back there, the other lab you guys can do, we'll save this one for the future, but I just want to plant some ideas now so that you guys know what differences to look for. In the future, probably sometime next week, I'll have you guys do the elastic version, where these are like bouncing off each other, baboing. That's to say, like baboing. Okay. And so this one will be trickier, the one you guys will do next week, because post collision, you're gonna have 2 carts each doing their own thing. So you have to have somebody on a stopwatch for each one of those. Okay, but not today. Today is actually a little bit more straightforward. Inelastic, they stick together, and so they're all doing the same thing post collision. Right? So you guys can put several names on the paper. Just do 5 different trials. I showed you guys one trial there. And pop this in the grade tray by the end of class. Right. You guys got any questions? I'll walk around and help you guys out.